Hello and welcome back to this pre-narculus production on graphing log functions. Now we're going to try to graph some log functions with some transformations. Okay, so we're going to try to put it all together here. All right, name the parent, name the transformations, move those key points in that asymptote, and then make the graph. Okay, like we've done similarly in class. All right, so let's take a look at our first graph. We're going to try to graph y equals log of x minus 3 base 2 plus 1. Okay? All right, so the first thing we want to do is identify the parent. The parent graph is going to be y equals log of x with base 2. That's going to have no transformations on it. Now, if we want to graph this, we can't really do much with it if it's in log form, so we're going to switch it, convert it to exponential form, and we'd have 2 to the y is equal to x. So now let's talk about our key points on the graph of 2 to the y equals x, which is really just log of x with base 2. In a different name. All right, so we got three numbers. We're going to plug them in. We're going to plug in -1, 0, and 1, and we're going to plug them in for y, right? We're going to put them in for y here, because then it'll give us an answer for x. So 2 to the -1 will give me 1/2. 2 to the 0 will give me 1, and 2 to the 1 will give me 2 for x. This is a log graph. Log graphs have vertical asymptotes, okay, that start at the line x equals 0 and then can be transformed depending on how we get our values. All right, so let's talk about the transformations. That's the key points on our parent, but let's see what happens to this graph. All right, so transformations on this graph. We have this -3 that's in parentheses with the x, so that means we're going to move the graph right 3. So we're going to take the x's and add 3. And then the +1 out here is going to move our graph up 1. So we're going to take the y's and we're going to add 1. So to move these points, we're going to take the x's and add 3, take the y's and add 1. So if we do that to all of these points, including the asymptote, we are going to end up at 1/2 plus 3 is 3.5. -1 plus 1 is 0. 3 and 1 is 4. 0 and 1 is 1. And then 2 and 3 is 5. 1 and 1 is 2. And then my vertical asymptote at x equals 0 gets moved, gets added 3 to it. So it's going to end up at x equals 3 for our vertical asymptote. All right, so let's graph our vertical asymptote on our graph here. Here we go. It's at x equals 3. It's a vertical line, goes right through the x-axis at 3. And now let's graph our 3 points, and that should be enough to go ahead and make our graph. We have 3.5, 0, so we're going right 3.5, but not going up or down. Right 4 up 1, and right 5 up 2. And now the graph tries to stay close to the asymptote here, okay, and then passes through these 3 points and swings itself away. And there's our graph. Okay, there's the picture. There's the graph for y equals log of x minus 3 base 2 plus 1, using transformations and the parent graph. Okay, there's our first graph complete. All right, so let's try one more. We're going to try to graph y equals -2 ln x. All right, so let's start again. Same thing. We're going to talk about the parent graph. The parent graph is y equals ln x. Now remember, ln x is just a fancy way to say log with base e. Remember, e is that number that's approximately 2.718. It's the natural log. Okay. And so we're going to switch this form to exponential, and we get e to the y equals x. So now let's talk about our key points. Remember, we do our key points, and we write our values with e, and then eventually we worry about how much that might be on the graph where we would move to. So remember, we're going to plug in numbers for y this time. So we're going to plug in -1, 0, and 1 for y, and that'll give us values for x. E to the -1 is just 1 over e. E to the 0 is 1. E to the 1 is e. And this is a log graph, the natural log, but it's a log graph nonetheless. So it starts with a vertical asymptote at x equals 0. So now let's talk about the transformations. This negative that's out here, okay, is going to reflect this graph in the x-axis. It takes the y's and multiplies them by -1. And then my second transformation is a vertical stretch by factor 2. It's going to take our y's and multiply them by 2. So the x's are going to stay the same. The x's are not going to change this time. The y's are going to get multiplied by -1 and by 2, so we'll just multiply them by -2. And let's see where we end up. So the x's stay the same, so we have 1 over e still. -2 times -1 is 2. And then we have 1 stays the same. -2 times 0 is still 0. And e stays the same, e comma 1. So 1 times -2 is -2. And the x's stay the same. So that vertical asymptote at x equals 0 stays there. It doesn't move. So let's graph that first. Here's our vertical asymptote here on x equals 0. Goes right through x equals 0, right through the y-axis. Or it is the y-axis. And now we have 1 over e. Remember, 1 over e is about 1 over 2.7. Okay, 2.71. So it's somewhere between a half and a third. All right, so it's somewhere between a half and a third, and then we're going to go up 2. So we'll do this. There's our point there. And then we have 1, 0. That's an easy one to graph. And finally, we have e -2. E is 2.718. So this is the point 2.718, comma -2. So we're going over almost to 3 and down 2. There's our point there. So this graph wants to stay close to the asymptote. Okay, and then it's going to swing away from it as it passes through these 3 points. And away it goes. And that is the picture of y equals -2 ln x. Okay, so that's how you graph these things with some transformations. All right, as always, thanks for clicking.